Hey everyone, and welcome back to this explainer. Today, we're turning our visual chalkboard into a literal mathematical masterclass. We're going to mathematically prove how classical electrodynamics isn't just standard physics, it's actually derived directly from the abstract arithmetic geometry of the Adelic Langlands Program. We're going to look at the very fabric of reality through the lens of pure math. So let's jump right in.
Here is a quick look at our agenda for today. We'll start with part 1, the arithmetic shadow. Then we'll move through deriving the Larmor formula, the math of space-time constants, higher-order QED corrections, curing the ultraviolet crisis, and we'll wrap up with the rigidity of primes.
All right, let's kick things off with section 1, the arithmetic shadow.
Okay, you're probably super familiar with the classical Larmor formula for radiated power, right? Power equals q squared over 6 pi epsilon naught c cubed times acceleration squared. We usually treat it as this foundational, rock-solid physical law. But what if it's not? Under spectral projection theory, this equation is literally just a low-energy, semi-classical shadow. It is merely a projection of much deeper arithmetic invariants.
Now think about this mapping, because it is absolutely fascinating. See how these everyday macroscopic variables translate to advanced arithmetic architecture? The charge, q, actually maps directly to Logos field theory as an automorphic character. The acceleration, a, that's J theory, representing local curvature deviating from an ideal harmonic flow. And the radiated power, P itself, is spectral projection theory in action. It's the literal rate at which information leaks back into the underlying quantum matrix.
Moving right along to section 2, deriving the Larmor formula.
Before we get lost in the heavy math, here's our roadmap. 6 clear, precise mathematical steps. We are going to extract that classical radiation term straight out of the fluctuating quantum matrix by perturbing the geometry, evaluating the action, and isolating the classical results.
Step by step, look at what's happening here. First, we introduce electromagnetism by perturbing the geometric Dirac operator, that D right there, with an inner fluctuation. This brings in our vector potential A and that automorphic character Q. Then, in step 2, we define the actual physical action using the Chamseddine spectral trace. So we get the trace of a regularized function of the Dirac operator squared, all over a physical scale, lambda.
Now here is where the absolute magic happens, the asymptotic heat kernel expansion. When we expand this trace, different levels of physics literally just drop out. Levels A0 and A2, those give us gravity and cosmology. But right here at level A4, we isolate the universal Yang-Mills gauge fluctuations. When you multiply this by our cutoff parameter, it simplifies perfectly into the standard Maxwell kinetic action. We've literally just grown electromagnetism out of pure geometry. How cool is that?
Let's follow this cascade down. We start with a spectral source, dropping in a localized point that deviates from its ideal J-theory flow, which gives us our current density. Then, varying that a force spectral action spits out the energy-momentum tensor. Finally, we integrate the resulting Poynting flux and boom, the exact classical Larmor term falls out flawlessly at equation 4. It turns out what we call radiation is really just high-energy geometric invariance cooling down macroscopically.
Section 3, the math of space-time constants.
Let's talk about space-time constants, specifically the speed of light and vacuum permittivity. In this mathematical framework, these are absolutely not arbitrary empirical numbers that physicists just measure in a lab and blindly accept. No, they are rigid, global invariants of the underlying arithmetic algebraic variety. They have precise geometric origins.
The explicit mathematical identities here are just stunning. The speed of light, c, acts as a global modulus. It dictates data decompression across prime places, perfectly balancing the global canonical Arakelov height and the number of field discriminant. And vacuum permittivity? It strictly governs the arithmetic self-intersection volume of the gauge sheaf. To put that into perspective, space-time constants are, quite literally, arithmetic volumes.
And through the Quillen metric math shown here, we can prove that our spectral cutoff parameter, F4, is strictly locked to the topological and arithmetic volumes of that underlying Arakelov scheme. We're finding an explicit algebraic bridge, where the analytic regularization perfectly equals the Arakelov height. So this cutoff isn't just some free parameter we get to tweak to make the math work, it is mathematically bound.
All right, moving into section 4, higher order QED corrections.
So, if A4 gives us classical electrodynamics, what happens if we push the expansion even further? Let's look at the A6 and 8 Seeley-DeWitt coefficients. We find something incredible.
Quantum electrodynamic effects actually cool out of the Adelic matrix directly at the classical spectral level. This is a huge deal. It means you don't even need secondary field theoretic quantization loops. The geometry already natively contains these higher derivative corrections.
Focus on the mathematical invariants for a second. While A4 gives us standard Maxwell theory, the A6 invariant yields the Ewing effect, that's vacuum polarization, and it actually incorporates acceleration gradients, or jerk, to smooth out radiation reactions. Then, moving down to 8, those quartic field strength trace terms natively induce the Euler-Heisenberg effect of action. That literally gives us nonlinear light-by-light scattering, straight out of the geometry.
Section 5. Curing the ultraviolet crisis. Now our derivation works perfectly, but we hit a massive speed bump at extremely small sub-Planckian scales. A catastrophic mathematical crisis, really. Look at the denominator in this self-energy trace equation. Lambda m minus lambda n. If continuous relationships hold all the way down, those eigenvalues could cluster infinitely close together. And if that denominator hits 0, it's the mathematical equivalent of an infinite point charge self-energy. You'd get infinite radiation and a total ultraviolet divergence.
Which brings us to the big question. How does the arithmetic framework prevent an infinite divergence? Since continuous acceleration implies infinite sub-Planckian radiation, what exact mathematical mechanism steps in to stop reality from just tearing itself apart? How does the math survive the singularity?
Well, the answer is spectral level repulsion. Look at this Wigner-Dyson surmise graph. The Gaussian Unitary Ensemble, or GUE, acts as this incredibly rigid matrix ensemble. As eigenvalue spacing approaches 0, the probability of finding two near-identical eigenvalues vanishes quadratically. It literally drops to 0. This creates a hard physical boundary, a minimum spectral gap that actively blocks any arbitrary sub-Planckian acceleration.
And the exact mathematical cancellation happening under the hood is just elegant. In the self-energy integral, you have an inverse s coming from the coordinate singularity. But the sine-kernel pair correlation function from that GUE filter throws in an s-squared dampening field. Mathematically, s to the negative 1 multiplied by s squared equals exactly s. The singularity is beautifully softened into a smooth linear 0. The energy remains strictly finite.
Finally, Section 6. The rigidity of primes.
We've proven the derivation and cured the ultraviolet crisis, which leads us to this profound semi-classical freezing protocol. Because GUE statistics perfectly match the spacing of the non-trivial zeros of the Riemann zeta function, thanks to the Montgomery-Odlyzko law, any continuous acceleration trying to emit infinite radiation is intercepted by this GUE repulsion. It completely freezes the spectrum into a discrete grid right at the Planck scale, entirely blocking that infinite self-energy collapse.
I want to leave you with this final incredible thought, straight from the math. The electron does not collapse into an infinite self-energy well, because doing so would require fracturing the underlying arithmetic architecture of the global number field. So think about it. Is the stability of our entire physical universe, from a glowing light bulb to the continuous radiation of stars, ultimately anchored simply because prime numbers refuse to fracture? Thanks for joining me on this deep dive in today's explainer. Keep questioning and keep calculating.